Okay. So the first thing to note here is this test covers chapters 11, 12, 13, and 14. Okay. The final exam, because we're currently working on chapter 17 right now as we're doing this review, the final exam covers all the midterms and 15, 16, 17, and 21. There is an extra emphasis on these 4 chapters on the final exam because they haven't been on the midterm exams. So I'd expect at least one question from each of those chapters, like one big long question from each of those chapters, plus a couple other long questions from the rest of the semester, and then some shorter questions to pick up the topics. So that's really where we're at right now in the semester. Okay, so the final exam is generally, so a regular test is 45 minutes. The final exam is 180 minutes. A regular test is open for ballpark 30 hours, Thursday evening to Friday night. I need to check when the final exam is due. I think it's due Thursday night, so I think it's due, right, because this is being recorded. Make sure I get it right. MSVU exam dates. I just Google it every time. Exam schedule, fall, Control F, Whitaker. Yeah, Thursday, 10 p.m. Okay. Yeah, so I think I probably should have looked at the, I think it closed. Yeah, I think it's Thursday the 15th. The Thursday of exam week. There we go. I'll just be at 10 p.m. That's a big change. The registrar sets the time so you don't have those extra 2 hours before midnight. It opens no later than Tuesday at 10 a.m. So at minimum, you should have basically all day Tuesday, all day Wednesday, all day Thursday to do it. My sincere, unofficial hope is that I can have the test ready for Monday morning, but I don't want to promise that to anybody because the final exam takes a lot longer to create. So no later than Tuesday, but you might have Monday as well. If you are, so I recommend to everybody to practice using the save and resume feature. And you can do that in the exam settings test because most students don't seem to use the save and resume feature on the midterm tests. It's 45 minutes. Students are comfortable sitting down and doing that in one go. And often students finish before the 45 minutes. With the final exam being 3 hours, many more students use the save and resume feature, and you should absolutely know exactly what it's going to do. Because when you use the save and resume feature, any question that you've already seen before you hit save, you cannot go back to. And that will often trip students up. They'll like go on to the next question and then choose to save and resume, but they won't be able to come back to that question they were on. And that trips them up. And there's really nothing that we can do about that. Any other questions about like logistics like this? Okay. So on an important thing to note is that right now, this first question we're going to talk about is a chapter 14 question. And I'm going to point out what makes it a chapter 14 question. And you're going to be like, well, Doug, this doesn't really feel like all the questions on this feel very different. I don't see what the hard part about identifying chapter 14 is for this. And the reason why I'm pointing this out is because on the final exam, the questions are going to feel much more similar to each other because we're going to have 15 and 16 and 17 and 21 as well. So the chapter 14 feels kind of like those, and so it's harder to pick out which one is which. So this question is based on real Canadian census data. A company is going to make products designed for people who have long commutes. They want to break into Nova Scotia. They define a long commute as one that's more than 10 kilometers. The company is only going to expand into Nova Scotia if the proportion of commuters who have a long commute is more than 0.46. They hire market researchers to conduct a survey to gather data. Unknown to the company and market researchers, the true proportion of Nova Scotian commuters who have a long commute is 0.422. If the market researchers take a survey of 517 Nova Scotian commuters, what is the probability that more than 46% of their sample will have a long commute? So the key thing here is that what separates this question from what makes this question a probability question as opposed to a statistics question is this phrase here. Unknown to the company, the true value is 0.422. Why on earth would the company hire a market research firm to figure out the true proportion of commuters if they knew it? This number here is the true value. And we don't usually know the true value when we're doing statistics. That's what we're trying to figure out. So anytime you are told that you have a true value in a problem, you should immediately be thinking this is a sampling distribution question. Often, here's like a meta test taking tip. Often I use census data to come up with these because the census is the true values. And so meta test taking tip, if you see a census problem, that's often a big clue that it's a sampling distribution problem. And sometimes I'll phrase it as like unknown to the company, the true proportion is this, or the company knows the true proportion, and what they're going to do is they're going to evaluate how well their sampling plan worked. If we say that, let's say that 5% of people in Canada live in Nova Scotia, if you take a random sample of Canadians, gosh darn, 5% of your sample approximately should be Nova Scotians. If not, you don't have a representative sample. That's a way of checking. And so that's another way that I could phrase this question. Okay, so really what we're doing here, we're going to answer this question in parts, but already we're talking probability that more than 46%. More is a right tail question. I'm not even drawing this to scale, 0.46. This is the answer to the question, whatever that area is. Now we got to figure out what that is by doing it in parts. Oh, I guess question 1 is right here. So the first question is, what is the mean of the sampling distribution of p hat, the sample proportion of commuters of the long commute? Now, one thing so the central limit theorem tells us a bunch of stuff. If you want, we could even check to make sure the central limit theorem applies. 517 times 0.46. I don't know what that number is, but it's more than 10. And 517 times 1 minus 0.46. I don't know what that number is, but it's bigger than 10. And so we're good here. The central limit theorem tells us that the sampling distribution of p hat is centered at the true proportion. There's no calculation to do. It is a number that we just read from the problem. If you are asked to do this, give the exact number that you were told. Don't round it at all. So the first question is literally pick the right number out of the question text. Any questions on this so far? Great. Okay. What is the standard deviation? So what is the mean? The mean is the center of this distribution. The center of the normal distribution that we're going to be using is the mean. And it's centered at the true value, which is p equals 0.422. Exactly, yes. So the next question is, what is the standard deviation of the sampling distribution of p hat the same proportion of computers with a long commute? So right now on this picture we don't know how spread out. Is this a really tight normal distribution or a very spread out one? We don't know, and so we need to quantify that with the standard deviation. And so the standard deviation formula here, the standard deviation of p hat is the root p1 minus p over n. Now this looks a lot like a bunch of things you've also recently seen. Huge, massive caution. Not p hat. Not p hat. We do not use p hat here. The central limit theorem, what we're talking about here, is based on the mean and standard deviation are based on p, not p hat. So we're going to use p for these calculations. The only reason why we don't use p for the other formulas like chapter 15 and 16 is because we don't know it. If we knew it, we would want to use it. And in this problem, we happen to know it. In a hypothesis test problem, if we don't know the true value, we go with the hypothesized one, p null. In a confidence interval problem, if we don't know the true value, we go with p hat. But here, because we know the true value, we don't substitute p hat. Using p hat, though, is the #1 mistake that I see students make at this part of the problem. Okay. So now we just have to compute. We have to just, this is the square root of 0.422 times 1 minus 0.422 divided by 517. Make sure that you can do the calculations here on your calculator. You should get, say, the square root of 0.000471791, which is 0.02172073. And it says round to 3 decimal places, 1, 2, 3. And so we look behind, and that is about 0.022. Exactly. And common calculator mistakes that I see students do is not including the 517 in the square root, or doing other calculator. Make sure that you can get each one of these values that I've just written out here if you are uncomfortable with this sort of problem. Doing it in steps is a great approach. Okay. So now what we want to do is, what is the z-score for determining if more than 46% of commuters in the sample have a long commute? Okay, so we said this was centered at 0.422. I'm just going to use my calculator. This should be 0.444. I'm just going out 1 and 2 standard deviations. This should be 0.464. So what we're looking for here is the area 0.46 to the right of this. And so our Z value, Z equals P hat minus P divided by the standard deviation of P, which is P hat minus P over the square root of P times 1 minus P hat over N, which we just found all these things. So we have 0.46 minus 0.422 divided by 0.022. Note here, it says use your values from parts 1 and 2. Due to the way Pearson does the rounding and how precise these answers are, when I build the questions in Pearson, it's doing the division. I make sure it uses the rounded values. It's maybe not the best, most scientific way to do it, but it's the way of doing it when to make sure that students have the best, like the fewest technical challenges to getting full credit. Exactly. So this is going to be 0.038 divided by 0.022, which is 1.727272, etc., which we round to 1.73. So Z equals 1.73. Now you might be saying to yourself, well, Doug, 1.73 is all well and good. But what if I set up this problem differently? What if I wanted to find the left tail area and use symmetry and be like, I'm going to find the left tail area and then just look that up and like, I know that's also the right tail area. And so my Z value is negative 1.73. That's a very, like, it's a wonky, it's a less straightforward way of doing the problem, but it's an appropriate way of doing the problem. I'll let you all in on a little secret. When I build this question, I accept positive and negative Z. So you don't really have to worry about the sign of the Z value. Just make sure you get an appropriate one. The next question, though, is that right tail one for the more than 46%. There is a right answer here. You have, whether you have a positive or negative Z value, you have to get the correct probability. So what we do here, let me find a table Z. So I indicate that it's right-tailed by saying more than. I will not specifically tell you right or left. You have to get that from the context. Oh, you can't see my table Z thing. Is the way I'm sharing my screen. Well, at this, if anyone wants me to go over that in a bit, I will. But what we're trying to do here, 0, 1.73. We get an area to the left from table Z, just looking this up as we've been doing since chapter 5. This is 0.9582. But remember, that's not what we wanted. We said from the very beginning that we wanted the right tail. And table Z gives you area to the left. So we have to do 1 minus 0.9582 to get 0.0418. Now you might be wondering why I use multiple choice for here instead of having you type it an answer. Again, if you rounded or got something, got a value that's close to this, because maybe you got Z of 1.74, I want you to be able to figure out to pick the closest one to get full credit. Where did I lose you?
Hi.
Hi.
So, I'm a bit lost. The question said more than
Yes.
46%, and more than it's like positive, right?
Yes.
That's the
It's
right
the
tail.
right tail.
So
Yes.
why are we not using the 0.5958? Rather, we have to use 1 minus 0.9582.
Because this value that we look up from table Z always gives us a left tail area. Table Z always tells us, when you look something up in table Z, if that's what you use, it always gives you the left tail.
Okay.
And we want the right. And so we know that it's the complement rule, that the left tail plus the right tail equals 1 always. So we can just do 1 minus the other to find the missing one.
Okay, so if I get a question like this, after calculation, all I have to do is 1 minus.
If you get a more than question, yeah. If you get a less than question, if the question had been, what is the probability that less than 46% of their sample will have a long commute, then the answer is 0.9582.
Okay, okay. All right. Thank you.
Welcome. All right. And so that's it. So there's only a 4% chance that more than 46% of their sample is going to have a long commute. So it's unlikely that they're going to sort of make the wrong decision and expand into Nova Scotia because they think there's enough people when there aren't. If we were in person doing like sort of a paper-based test, I would probably have a part 5 to this question that sort of asked you to make some sort of like, use this information to explain to the company what this, try to tie it all together with a very messy kind of sentencey answer. But it doesn't work as well on computer tests, so I don't. Okay. Any questions before we start question 2? All right. So I loved this data set when I found it because I actually was able to, they're actually normally distributed. If you look at if you only look at like, they're actually normally distributed data, which is so rare in the real world. Okay. So Fisheries Oceans Canada collected a bunch of eel data, and they collected the length of eels in 2 different bodies of water in Nova Scotia. And we were told the means and standard deviations for the eels in each of these bodies of water, the lake and the river. And we are going to compare the lengths of these eels. First question is, how many centimeters larger are the eels from the Bras-d'Or lakes compared with those caught in the Mira River? And so right away, we're saying, okay, how much larger are the lake eels than the river eels? Well, the lake eels are bigger. And so what we're actually going to do here is we're going to do 48 minus 45, which is 3. Now, why are we doing that? Well, it's because it's really mu lake minus mu river, which is 48 minus 45, which is 3. They're on average 3 centimeters longer. What is the standard deviation of the difference of eel lengths between those caught in the lake and the river? Well, we have this. So now we're talking about the difference. we want to compare lake minus river, as it were. Because that's what we're doing here. We were doing lake minus river. So I'm going to write this here. I'm going to write sigma squared 1 minus sigma squared 2. Any thoughts about what I just wrote? Is this right? You might guess that because I'm stopping and waiting and asking if this is right, that is in fact not correct. And that's true. How do I change this to make it correct? This is the #1 mistake students make at this part. Okay, I will tell you. Plus. We always use plus in the variance or standard deviation formula, regardless if we're asking for the sum or difference. We always use the plus there. Now, if we keep going with this, so the idea, sort of the intuitive idea here is that if the eels in these bodies of water aren't related to each other, if they're not affecting each other, if we have a certain amount of variability in our data and we combine it with other data that has its own variability, the variability is just going to go up. We're going to get even more variability. We're always adding variability. It's not ever, we're not saying, oh, we've got eels from the lakes, they've got their own variability. We've got eels from the river, they have their own. We're going to combine the two and get less variability somehow. That doesn't really work. It's always plus. So, and the other common thing that people miss is the sigma squareds. Make sure we use 36 and 64. 6 squared and 64 and 8 squared. Now be careful, because if you use the minus, it's not, the answer is not going to be 0. If you do it, if you did the minus order correctly, you would get a negative answer, which you can't do. You would get minus square root of minus 28, which is not going to work. Or you'll get the square root of 28 if you well, I mean, so if you end up with a negative under the square root, students try to do a lot of things to make it right rather than stopping and going back to figure out where they went wrong. If I were thinking, I would have had 5 point. Oh, I do have 5.3. There we go. I was like, I should have had square root of 28 as an answer. It is 5.3. Doug, you're wrong. It's not square root, it's 10. 10 is the answer. Oof. Okay, so 10 is our answer. And that's that. Okay. It actually turns out that they are normally distributed. The lengths are normally distributed. So we're going to answer the following question. Probability that a randomly selected eel from the lake is larger than a randomly selected eel from the Mirror River. So a few things to note here. This is a two-part question. Setting this up mathematically properly might be more confusing than we expect it to be. But that's the way the cookie crumbles. I'll show you how that works. The other thing to note is, okay, the lake eels are bigger than the river eels. What's the probability that a randomly selected eel from the lake is bigger than a randomly selected eel from the river? That should be more than half. More than half the time, if you pluck an eel out of the lake and pluck an eel out of the river, the lake should have a bigger eel on average. So our answer here, whatever our answer here is for the probability one, it should be more than 0.50. If you don't get something that's more than 0.50, that's a big hint that something went wrong, because that doesn't make sense with the context of the problem. Okay, so how do we do this here? So what we're asked to find here is the probability that an eel from the lake is longer than an eel from the river. If we use a teeny bit of algebra, we can rewrite this as the probability that the eel from the lake minus the eel from the river is greater than 0. So what we have is a greater than, like a right tail problem here. Written another way, same thing, probability that 0 is less than x lake minus x river. And so what we can do here is we can do z equals sort of our value of interest minus the mean over the standard deviation. The value of interest is 0. That's what we figured out here. That's the number we want to compare to. We just said the mean was 3, and the standard deviation is 10. So this is minus 0.30. And so if we were talking about a normal distribution here, that's a terrible normal distribution. That's a better one. Okay. If we were talking about a normal distribution, we want to put negative 0.30. And which tail are we going to want to do? The left or the right? Indeed, the right. And there's two ways to know that. One is we had this, we're phrasing this as the difference is greater than 0. The difference is greater than 0. The other is we said that the probability should be more than half. In order to get our answer to be more than a half, we've got to be picking up the right tail. The other side, the left tail, is less than half here. Okay, so our answer to this was z equals negative 0.30. But again, when I code these questions on the test, I will accept either usually, because if you got 0. If you did 0.3, there's still a way to get the correct answer with that. So the Z value, the sign doesn't make so much of a difference to me. And so finally, what we've got here is, what is the actual probability? Well, it is centered at, for a standard normal distribution, it's centered at 0, minus 0.3. This is terribly not to scale. We want this area to the right. We look up minus 0.30 on table Z. This one. What's up? I mean, ask your question in the chat, and I'll come back to it. So the more than 0.50 is from thinking about, just thinking, if you have a bucket of eels from the lake and a bucket of eels from the river, the lake eels, on average, we're saying the mean length is longer than the river eels. If somebody said, I'll give you $5 if you pick a bucket, or if you pick the bucket that's going to have a longer eel if we pull it out, and they pull out one eel from the lake and one eel from the river, more than half the time, it's going to be the lake is the longer one, because on average, the lake eels are longer. On average, the lake eels are longer. So it's really just sort of thinking through the context of the question. So if we look at minus 0.30 on the Z, we're going to get 0.3820, 0.3820. And so we use that complement rule again, 1 minus 0.3820, to get 0.6180, I believe. And then it says round the answer to the 0.618. Any questions on this? This is certainly one of the more complicated problems that would be on this test. But I would expect something of comparable difficulty to be on the test. This is, I would say, a standard problem. And so you should definitely know how to do it. Any, okay, keep going. All right, so we've got a very generic problem here, but this is like a probability fundamentals question, sort of like the addition rule for disjoint events, the multiplication rule for independent events, complement rule. Those rules are going to have their own question, basically. So sample space for an experiment consists of 5 sample points of probability. Okay, great. If we add these together, what should we get? We should get 1.0, 0.07 plus 0.19 plus 0.32 plus 0.31 plus 0.11. Hey, look at that. We get 1.0. Each of these events can only happen, or they can't happen at the same time. So these are going to be disjoint or mutually exclusive events. And so when we see an OR question here, probability of 1 or 3 or 4, is probability of 1 plus probability of 3 plus probability of 4, which is 0.07 plus 0.32 plus 0.31, which is 0.70, I believe. Yeah. Uh, 1 or 2 or 5 should be the same basic approach. Either 1, 2, or 5. That's going to be probably 1 or 2 or 5. That's going to be 0.07 plus 0.19 plus 0.11 is 0.37. 4 does not occur. 4 does not occur. That's going to be not 4. It's 1 minus probability of 4, which is 1 minus 0.31, which is 0.69. And then we have this question 4. So when 2 dice are rolled, is the event the first die shows a 5 on top independent of the event the second die shows a 5 on top? The idea of independent versus disjoint or mutually exclusive is really important. Independent means the outcomes don't affect each other. Disjoint means they cannot happen at the same time, which means they absolutely do affect each other, because if one occurs, the other cannot. So, hot take, if you roll 1 die, does that affect the other die? I'm hoping that you would say, no, rolling the left die doesn't affect what the right die is doing. So they are independent. And so we can eliminate these options here. So the 2 events are independent because they are mutually exclusive. This is impossible. You cannot have independent, mutually exclusive events. So it's not A. It turns out to be C. Okay. I'm going to stop sharing for just a second. I'm going to find something on the Pearson to show you. MLM. Come on. Assignment Manager. Chapter 11. Print.